everyone. So in this video, we will be discussing about the third problem of today's weekly contest, count number of texts. So we are like the problem states that uh, we are given a sequence of integers and we need to find out how many possible text messages can be formed from this sequence of integers. So for example, if let's say this is a sequence like 22233, then one text message can be formed if 2 is pressed once, and next time 2 is pressed twice, and next time 3 is pressed twice. That is one possibility. So second possibility can be 2 is pressed twice first time, so that become B. Then 2 is pressed once, then that becomes A. Then 3 is pressed twice, that becomes E. So basically we have to find total number of possible combinations of different text messages that can be formed using this sequence of integers. And since the answer can be huge, just we have to return it with some modulus. Okay, so let's try to solve this. So here I just listed out what are the possible texts corresponding to each integer. Okay, and this matrix denotes the count of integers, count of texts in each integer. So basically 2 can be pressed thrice because 2, like by pressing 1 you will get A, by pressing 2 twice you will get B, by pressing 2 thrice you will get C. So that's what 3 denotes. Similarly, like you can see 9 has 4 characters, so that's why this 4. So basically this matrix denotes the number of uh, alphabet in each number. Okay, so let's try to solve the problem. So let's say which we are given this particular string. So instead of worrying about total possible combinations, let's just figure out what is the last character. Like you are typing something, right? So let's just figure out what is the last character that you might have typed. So last character can be this, right? So you can just press 8 once and that is the last character. So in that case last character is T, right? And if the last character is T, what you are left with is find out how many possible sequences are there with this particular string. So basically you have reduced our problem. Initially the problem states that how many sequences are possible with the whole string. Now the problem reduced to how many sequences are possible with the reduced string, like the string with the length, uh, one less length. Okay, so that like you have reduced the problem. So similarly, like let's say the last character was not T, last character was this. Basically you have pressed 8 twice, so in that case you will get U. So last character is U, and now this, like these are the like how many possible strings are like how many possible sequences are possible with this string. If you can find out, you can just add it to this. So basically you can see the last what is the last character can be this, or last character can be formed from this, or last character can be found from this. Okay, because 8 has 3 characters, so 8 can be typed continuously 3 times and you will get one character. So that's what we want. We want the last character of the actual text. So if 8 is pressed once, last character was T. If 8 is pressed twice, last character was U. If 8 is pressed thrice, last character was V. So when last character was T, what you want is f of p minus 1. So let's say the position we like, this is the current position, let's denote it by p. So basically f of p denotes the total number of like we need to find out what is the value of f of p. Basically total number of sequences that is possible for a string ending at position p. Now we figured out the last character. So last character was either T or U or V. So when last character is T, number of possible string possible is f of p minus 1. when last character is u, number of possible sequences is f of p minus 2. When last character was v, number of sequences possible was f of p minus 3, right? So total number of sequences possible, like, see, you have some sequence and last character was t. Then you have some sequence, last character was u. Then you have some more sequence and last character was v. So total possible sequences that can be formed is this plus this plus this, right? So total number of possibilities with ending at t, total number of possibilities ending at u, total number of possibilities ending at v. So basically our answer will be f of p minus 1 plus f of p minus 2 plus f of p minus 3. Notice that we can't take this as last character because they like this will bring a definitely more than one character because 8 is pressed 4 times. So because 8 doesn't have 4 characters, so there are more than one characters, but what we are interested in is only the last character. So that's where the fourth, like the fourth one will not come. So hope the intuition is clear. So what we are trying to do here is we are just trying to find out the last character and then trying to reduce the problem into a sub problem of the same kind. So hope you get the intuition of recursion here. So now let's see how to like what is the actual states and of the recursion. So this is the, so f of position denotes the total number of possibilities, the total number of sequences that can be formed uh, with the string ending at position. Now if position is 0, it means there is only one digit. So with one digit you can only form one character, right? And that's like one character of only one kind. So if let's say the string is only 2, then answer would be a only, like you can't do anything else. So that's why written 1. Otherwise answer is 0 and we will try position minus 1. Like basically we are saying that uh, last character is just 8. Okay, now if like and then we will see if the previous character is same or not. So basically if let's say before 8 there is 7, so no matter what 8 will be the only only t is possible. U can't be possible because 8 is only one times, right? So 8 has to be pressed consecutively 2 times to get u. But because uh, before 8 there is 7, so that's where like only possibility is t. So that's why we are checking if the characters are same. Then try f of try position comma position minus 1. Basically if there is, if 8 is repeated 2 times, the last character is u. uh, we will try this. And if again position of minus 3 is also same, then try v, like if the character is 8. And otherwise if you have tried all this, notice that there are two characters with 4 consecutiveness as well, right? So a 7 and 8 numbers have 4 consecutive characters. So basically if it is same, like if position minus 3 is also same, uh, then try just see whether position, so this will be position. So yeah, so just see if the number is 7 or 9. If it is 7 or 9, just add position minus 4 as well, because that can also be one of the possibilities. So hope the approach is clear. Just to reiterate, what we have done is we have tried to just reduce the problem into sub problem. How we have done that? Basically we are saying what is the last character. Based on that last character we will just say how many substrings are, like how many texts are possible with remaining sequence, and that will be the total number of substrings with ending at u. Now similarly uh, we try all possible combinations of last character and then add them all. So that's the approach. Let's look at the code. So the code is simple. As discussed, we will see whether position is 0 or not. If it is 0, just return 1. Uh, and then and one more thing to just notice is this one more, like this state can be calculated, one state can be calculated more than one time, right? So that's where you have to memorize this recursion. So this is the memorization part. Basically, initially dp contains -1, and as and when we are calculating any position, we are filling that with the value. So if answer is not -1, it means it has been calculated before, so just return that. Otherwise, just see how many continuous same digits are there. So basically checking how many of the digits are equals to the current digit. So we are just checking for 4 continuous digits because that's what the maximum can be. So if continuous is 4 but last pressed key is 7 or 9, so basically we are doing the same thing, this entire thing, but in a different fashion. But what I've done is here, find the total number of continuous string. If let's say continuous is 4, then if the positions are not 7 or 9, like if the characters are not 7 or 9, because 7 and 9 can only have 4 characters. So if position is not 7 and 9, just reduce it to 3, and then try all possible all possible last character with all these continuous strings, and add position minus j to the answer. So hope the solution is clear. If you have any doubts in the question, please ask them in the comment section below. If you like the content, give it a like and do subscribe to the channel if you haven't already. Thank you.